So let's focus on seeing how we can do an example. Yes, we'll focus. So here is a homogeneous equation. Cauchy-Euler, x squared y double prime plus 3xy prime minus 4y equals 0. Now, if we assume a solution of this form, y equals x to the m, then m squared minus m, be careful, plus 3m minus 4 equals 0. Or m squared plus 2m minus 4 equals 0. Now, you got to remember where that all came from. It's going to be m squared minus m for the first derivative, or actually second derivative, plus 3m for the first derivative, and then minus 4. Keep in mind, y double prime is m squared minus m times x to the m minus 2. And y prime is m times x to the m minus 1. So now you see where this came from. And it's not what you think. Be careful you don't say m squared plus 3m minus 4. It's not that. So, now that we've got this characteristic equation, and we can easily use the quadratic formula on that, and we will get -1 plus or minus square root of 5 as roots. And nothing's imaginary, so the solution for the equation is c1 x to the -1 plus square root of 5 plus c2 times x to the -1 minus square root of 5. Sure. How about this one? 4x squared plus y double prime plus y equals 0. If we assume a solution of this form, then 4 times m squared minus m, because m squared minus m times x to the m minus 2 is what we put in for y double prime, plus x to the m equals 0. So we wind up with this equation, which has a double root of m equal to 1/2. So the solution, y equals c1 square root of x, that's x to the 1/2, plus c2 times square root of x times ln of x. And we've got it. Okay, let's look at one that's a little uglier. How about this one? X squared times y double prime minus 7xy prime plus 41y equals 0. So if we assume a solution of this form, then m squared minus m, that comes in from this term, minus 7m from this term, plus 41 is equal to 0. So simplifying that, we got m squared minus 8m plus 41 equals 0, which certainly is a quadratic equation. We can solve it by formula, but we're going to get some imaginary solutions. So 8 plus or minus 64 minus 164 over 2. Well, that's 8 plus or minus -100 over 2. So 8 plus or minus 10i over 2. 4 plus or minus 5i is the solution to this equation. So x to the 4th from this real part, 4, and then plus c1 times cosine of 5 ln of x plus c2 of sine of 5 ln of x. If you're wondering where that came from, let's go back up here and look at case 3. See? X to the a, that's the real part, plus c1 cosine of b times ln of x plus c2 sine of b times ln of x. Hopefully you're good with that. So, that was some pretty good examples.
I'm falling asleep now.
Okay, well, we'll end this video and do another one.